is a project for Group 17 ICPS. Accident prevention and alert system in hilly terrains. We used 4 ultrasonic sensors. You can see the path, the lane and the curve, and a Raspberry Pi for this project. And these 2 devices are the outputs you can see on both sides. And this is a user interface. We also had a website which is connected to a central page.
This is the website, and this is the Raspberry code that is powering up this whole system. Actually, this code provides Firebase connection, and whenever there is a abnormalities in the road, it will send the data to Firebase. This is the code, and in the website we can add the text so that the mobile users can see any notification, and we can update any notification.
Like as you can see, the admin sent a hi message to all the users, and you can see there is a notice called hi, and if there is a message called for example damage on road, you can like see the admin, he just updated it. Here there is a notice damage on road. You can also see like, yeah, you can see the damage on road.
This is the Raspberry Pi code, and it takes the sensor data from these pins, and I make a threshold of 50 and tolerance 10 and duration of 5, and basically it's based on this is the logic for the processing of the data, and based on the conditions it will make a decision 0, 1 and 2 means 0 means no blockage, and 1 means a warning, and 2 means blockage. This is the React code for the website. This is the website, and this is the React code, which basically has the Firebase to fetch for a period of time with a repetition in a loop, and I use the use of it and use state. This is the code. And this is the code for the app, which is basically this. This is for the home page. This app also fetch the Firebase for every 1 second, and this is for the indication page. And the app.main.js. Thank you.
You can also see an user interface. Like if we have a blockage for more than 5 seconds, you can observe that road has been blocked at exact time. Have a safe journey. This message will be sent to the user, and if we remove, if there is no obstacle, quickly turns to no blockage detected. As you can see, this sensor is named as 1, this one has 2, this has 3, and this has 4, which means 1 and 4's output is this screen, and 2 and 3's output is this one. You can see both of them are green, which means there is no obstacle in the lane and the curve. Both of them are 0. And now let's test one. See, after after there is an obstacle, you can see there's a change in lane 1, and then after a 5-second delay it turns red, and the other side is still green. And if I remove my hand, it turned green, which means there is no blockage. And if we test the same with the curve, this is the 4th sensor, there is a change and then to red. You can see curve sensor 4 as 2, which means there is an obstacle for more than 5 seconds. And then if we see, like I removed my hand from that place, so you can see it's green. And if we check the the 3rd sensor, you can see it's orange and it turns slowly to red. You can see the curve sensor 3 is 2, which means there's an obstacle. And if I remove my hand, it turned green. And at last, this is the 2nd one. I placed my hand, it turned orange. Lane sensor 2 as after 5 seconds it turned red, you can see. And I am gonna remove my hand, it turned green, which means now you can see both the screens are green, which means there is no